Again, we're looking to rewrite this as some integer plus a proper fraction. So let's take a look at it. And the first thing I would do is just look at the root of 3 over 2. And that is going to be, let's see, 1.5, right? So I'm going to say greater than 1, less than 2. All right, so then the key over here is I have to write that down as some integer, 1, plus some fraction. And let's write this down, root 3 over 2 minus 1. Let's just think about it for a second. Root 3 over 2 is 1 point something. 1 point something minus 1 is definitely a proper fraction. So I got my first number that I need, which is the 1. Then you take the reciprocal. And again, they're getting more nightmarish. There's no doubt about it. And that would be root 3 over 2 minus 1. I'm going to try to rationalize that. And that would be root 3 over 2 plus 1, root 3 over 2 plus 1. Let's see what you get there. You get root 3 over 2 minus 1, which is a half. Let's make sure of that. 3 over 2 minus 1, yeah, half. Top, you get root 3 over 2 minus 1, plus 1. And I'm really in the same rigmarole. I got to try to figure that out now. And I'm just going to keep writing it down. So it's really 2 times root 3 over 2 plus 1. And I got to figure it out now. And that looks like it might be some work. And let me write this down as 2 root 3 over 2 plus 2. And I got to get that integer. And before I do anything, I want to point out that that 2 root 3 over 2 let's take a look. Let me write this down. 2 plus 2 minus 2 plus 2 root 3 over 2. And yes, it does require some thinking. Let me get my eraser. I didn't mean to put that doohickey there. Is that the same thing as above it? It sure is. So let me write this over here as 4. This does take some thinking on my part. 4. And then I'm going to pull out a 2. And you get root 3 over 2 minus 1. Well, you know what? That's what I really wanted to get. I wanted to get that. And the reason for that's root 3 over 2 minus 1. Let's think about that. And I do have to think about it. It's 1 point something minus 1. I got to be careful about that. I want to make sure it's a proper fraction. And I got to think about it. I hate to say it, I do. So root 3, well, let's say root 6 over 2 minus 2. And we're multiplying it by 2. And this is the problem with thinking. I got to think through it. And the root of 6 is 2 point something. This cancels. And you get 2 point something minus 2. Yeah, definitely a fraction. This is good news. I'm ready to move forward on that. And yeah, it took me time to get there. I hate to say it. But I want to point out I got some numbers here to deal with. I've got the 1, and I've got the 4. And then I got to repeat this game over and over again. Right, so what am I going to do now? I'll write this one down. I need the reciprocal. And the reciprocal of this thing is going to be 1 over 2 root 3 over 2 minus 1. And then I got to multiply by the conjugate. It's work, isn't it? And I'm going to just do root 3 over 2 plus 1, root 3 over 2 plus 1. And what would you get there? Well, on top, you just get root 3 over 2. On bottom, you get 2. You would get 3 halves minus 1, which is 1 half, which is 1. So you're just getting root 3 over 2 plus 1. All right? That's a long round of work, isn't it? I'm still not there yet. And so I'm writing it down. And let's take a look. I'm going to say 2 minus 2 plus root 3 over 2 plus 1 is the same thing as, let's see if I did that right. Yeah, that's okay. 2 plus root 3 over 2 minus 1. And this is a proper fraction, which is what I want to get. So I got my third number in now, this one over here, and do reciprocal again. And what's that reciprocal going to be? Let's write that down. It's going to be 1 over root 3 over 2 minus 1. I want to point out we're back over here now. So I got my nice repeating pattern over here. 1, 4, 2, right? 1, 4, 2. And then it's going to go back to, you know, the 4 and then the 2. And it's going to bounce back and forth between the two. All right, let's make sure I did that right. I got the 1. And then it's going to the 4. Then it's going to the 2. And it's bouncing back to the 4. That looks good. So what do we got over here? 1, 4, 2, 4, 2, 4, 2, 4, 2, 4. Forever and ever and ever. All right? Let me just make sure I'm saying that right. 1, 4. Just give me a second here. Yeah, I'm going backwards. Yeah, that's okay. So I did it right. And then I write the convergence down, all right? 1, 1, 4, 1, 4, 2, 1, 4, 2, 4. Again, the first one's pretty easy to compute. Let me just remind you what this one looks like. It's 1 plus 1 over 4, which would be 5/4. What does this one look like? 1 plus 1 over 4 plus 1 half. What does that one look like? It's going to be 1 plus, let's see, 2, 8, 9. So it's 11 ninths, so forth and so on, all right? So, I mean, they're kind of tedious to do. And really, at some point, I got to cut to the chase and show you to use a computer to do that, right? And we're at problem number 13. And I think what I'm going to do is one, tell you my name, Ron Bannon, and my email address. That's Bannon, B as in boy, the @ symbol, NNON.US. Again, at some point, I got to go to a computer until the problems become different. It's a very tedious process, isn't it? And again, I want to remind you, in Wells's time, they were computers, but the computers were actually humans. And they actually called them computers. And what they did was they computed numbers, right? Like Wells would give them a problem like this and say, you know, carry it out. And they'd carry out the computations. And they were quite good at it, much better than I could ever be at it. They had a special talent for it. I just don't have a special talent for it. I guess if I practiced enough of these, I could get a special talent for it. But I'll be honest with you, to me, it's a lot of work, right? A lot of scratch work. And certainly when I do this on a piece of paper, it looks awful. And then when I type it up, I try to make it a lot neater. I really do. And I see the repeating pattern. And then I typeset it so it looks nice and neat. All right? But again, at some point, we got to start talking about using a digital computer, not a human computer. Thank you for paying attention, though.